Hey everybody, welcome back. So today we're going to be looking at computations with inverse trig functions. So we're going to be looking at, in particular, compositions of trig functions and inverse trig functions. So what I recommend for everyone to have by their side, make sure you have your unit circle and make sure you have your filled inverse trig function table because we'll be using that. Okay. So like we saw with compositions, or at least the composition video, whenever you're dealing with a composition like we have here in our first example, always start inside out. Okay, so we're going to start with this, sine inverse of 2. Okay, now since we're going to be evaluating an inverse trig function, let's go to our inverse trig function table. Okay, so here's sine inverse, and notice that the domain of sine inverse is -1 to 1. Okay, and what we were computing in our example was sine inverse of 2. So I want you to ask yourself a question. Is 2 in the domain of sine inverse? And the answer is no. 2 is not in the domain. So this computation would be undefined. All right, let's look at this. Sine of sine inverse of minus square root 2 over 2. Now notice in this case we're combining or composing a function and its inverse here, so you might be tempted just to cancel them out and say this is minus square root 2 over 2. But as we'll see, either in this example or the next example, that you can't cancel out inverse trig functions and trig functions when you compose them, because sometimes you'll get some weird things. So again, I recommend with this one, start inside out. Okay, so sine inverse of negative square root 2 over 2. Okay, so again, we're going to go to our inverse trig function chart. Okay, and we're trying to compute sine inverse of minus square root 2 over 2, which is in the correct domain. That's okay. Now I want you to look at our unit circle here. Remember, sine inverse only outputs angles between minus pi over 2 and pi over 2. Okay, so if we go to our unit circle, what angle will give us negative square root 2 over 2 as a sine value? So if we go here, okay, and I want you to look at the right half of the unit circle, notice that y is negative square root 2 over 2 at 7 pi over 4. Now 7 pi over 4, though, is not in the interval negative pi over 2 to pi over 2, so we're going to take the angle that lies on top of that, which is minus pi over 4. Okay, so this is really just sine of minus pi over 4. Okay, so sine inverse of negative square root 2 over 2 is not 7 pi over 4, it's minus pi over 4. Because remember, sine inverse outputs things between minus pi over 2 and pi over 2. Now, what is sine of minus pi over 4? Well, if we go to our unit circle, okay, sine of minus pi over 4, so minus pi over 4 would be this angle right here, 7 pi over 4. If we look at our y-coordinate, we get minus square root 2 over 2. Okay, so notice in this case, we did get minus square root 2 over 2, so these functions did cancel out. We can cancel them out in this case. But that's not always going to be the case, though. Let's look at this example. Cosine inverse of cosine of 4 pi over 3. Okay. So again, we're going to start with the inside. What's cosine of 4 pi over 3? Let's go to our unit circle. Okay, where is 4 pi over 3? 4 pi over 3 is down here in the quadrant. So cosine is going to be the x-coordinate, negative 1/2. So this is cosine inverse of minus 1/2. Okay, so now we want to evaluate, well, what's cosine inverse of minus 1/2? Okay, so we're going to go to our inverse trig function table. So here's cosine inverse. Notice minus 1/2 is in that domain, so we're okay there. But remember, cosine inverse only outputs angles between 0 and pi. So what's an angle between 0 and pi that would give us an x-coordinate of minus 1/2? So let's look at our unit circle. Okay, what's an angle between 0 and pi here? That will give us an x-coordinate of minus 1/2. And notice we have one right here at 2 pi over 3. So cosine inverse of minus 1/2, this is really 2 pi over 3. Now notice this is not, they didn't just cancel out, right? We did not get 4 pi over 3. Okay, so be careful. Sometimes when you're doing compositions of trig functions and inverse trig functions, they don't always cancel out like we think they will.